Hi, I'm Tim Davis, DevOps Advocate with M0. I wanted to start out by thanking you for coming to the session. Obviously, I wish we could be in person to do this. That's kind of, where everybody wants to be. We're in the millionth iteration of March 2020 at this point. It kind of seems like it's never going to end. But hopefully, things will start opening up soon and we'll get back together and be able to do conferences and meetups and things like that like we used to. Um, I want to thank the organizers of the event for having me and letting me, speak to you today. We're going to be talking about pitfalls of infrastructure as code and how to avoid them. So about me, I'm currently the DevOps advocate of an infrastructure as code automation startup called M0. Before that, I was part of a small group of people that created the cloud and developer advocacy team at VMware. Before that, I was still at VMware. I was in the networking and security business unit focusing on the NSX product. Before that, I was an enterprise architect with Dell Services, which is now part of NTT Data. Really focused on infrastructure, and previous to that, I was with SoftLayer and infrastructure operations, and before that, I was a systems engineer. The theme of all this is that my background is in infrastructure. That's kind of where I've been. And with that, while it is infrastructure, I've always been focused on the application because there's really no point in delivering infrastructure just for the sake of infrastructure. You're delivering infrastructure for the sake of running the app, which runs the business. So, it's one of those things where I've always had to kind of work with developers and figure out solutions with developers to make sure that they're getting the tools that they need and the infrastructure they need to develop and run the application that runs the business. And that's kind of where I sit right now in DevOps advocacy, is working between infrastructure teams and developer teams and product engineering and things like that to make sure that everybody kind of gets what they need, that we understand the needs of the developer, and also to kind of help bridge that gap between the two. So what is infrastructure as code? We'll kind of take this back a little bit for some folks that may be just starting out with infrastructure. Maybe you've been using infrastructure as code for a little while. There's lots of different places that you can be for this session to be helpful. So infrastructure, we all kind of know what this is. For the infrastructure folks, you've been building this, be it a physical server or even just clicking around in cloud consoles. Maybe you've scripted a little bit. And it's just one of those things where more and more developers these days are deploying their own infrastructure. Now, that's not saying that they're taking away the job of the infrastructure team, because that's still going to be a necessary job. All of that relevant experience and the wealth of knowledge is still going to be there. Just the same as for a developer, if an infrastructure team starts doing infrastructure as code, that doesn't make the developer go away. It just means that you need to kind of foster that communication a little bit better so that everybody starts talking. Now, when developers are going through and deploying things, they don't necessarily want to go into a console and click around and say next, 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 next in a wizard. They want to speak the language that they know best, and that's code. And that's really what the advent of the infrastructure as code model came from, is going to be these developers who are deploying stuff and they just want to write more code, click deploy, and have it go for it. And there are so many different options these days, but that's really kind of where it came from. And that's really where the journey begins, is where do you start? How do you get there? What kind of problems are you going to come up on? And that's kind of what we're going to talk about here. So what types of pitfalls or issues can come up with infrastructure as code? I have, good news and bad news for you. The bad news is that it's a lot. It's kind of both. It's infrastructure plus code. That's really what infrastructure as code is. So it comes along with all of the different pitfalls you can get with, infrastructure issues, and all of the pitfalls that come along with coding issues. Now, the good news for this is that you've probably got an infrastructure team, you've got a developer team, you've got all of that wealth of experience, you've got that knowledge to kind of bring together so that everybody can be successful in this new venture of doing infrastructure as code. And really, it kind of breaks down the, DevOps is dev and it is ops. It's not just developers who are doing operations now. It's really bringing those two groups together, making them speak a little better, so that everybody can be faster and be more successful. So let's break it down a little bit into some infrastructure pitfalls, and then we'll talk about a little bit of code pitfalls. The biggest infrastructure pitfalls, what we just talked about, is having that communication. Really going through, developers don't just develop things, and not know where they're going to deploy it. And infrastructure folks shouldn't just deploy stuff not knowing what's going to be there. So always making sure that you're designing that infrastructure specifically for the app, not just saying, oh, I need all of these servers and I need all of these, tools and I need all of this. Well, you may not. It all depends on what the developers need in order to run their infrastructure. One of the biggest things that you need to do when you're first starting out is you need to choose an infrastructure as code framework. Now, you may end up with a little bit of a couple of different things, but really, this is one of the biggest and most important choices that you're going to come up to. Now, there are a few different ways that you can go with this. You can break this down into cloud-specific frameworks and cloud-agnostic or multi-cloud frameworks. If you're going to be all in 100% on AWS, for instance, then CloudFormation may work for you. The only issue is if that down the road you need to work in a different cloud, or you're acquired, or you acquire another company that's working in another cloud, then you can't just take those scripts and up and dump them into the other cloud. CloudFormation is specific to AWS. For instance, if you go over to Azure, they have ARM templates. You can't just copy and paste one to the other. You'll have to kind of start over. Now, if you were to say start off with a cloud agnostic or multi-cloud framework like Pulumi or Terraform or TerraGrunt, it's not exactly the same thing as being able to deploy that same script there, but you've got a lot better starting point. You change the provider around, you may change a little bit around. It'll give you a little bit better starting point, and you can actually create it so that your scripts can be deployed to either cloud at either time, depending on how you write them. It's just one of those things where it gives you a lot better flexibility. There's also a lot more community support for these frameworks because of the fact that they're open source. You'll find a lot more support, a lot more modules, a lot more flexibility. For instance, AWS CloudFormation can only deploy to AWS. Terraform, there's modules for, at this point, basically every major cloud. There's even some SaaS tool providers in there, and even some hardware. I actually think that F5 has a provider that will work with a little bit of its hardware, depending on what you're doing there. So it gives you a lot more freedom, a lot more flexibility. You can do a lot more with it if you choose the cloud agnostic framework as opposed to the cloud specific framework. But really, if you're going to be all in on AWS, you're never going to change, then it doesn't hurt you to go that direction. Plus, you'll know that it's already got a lot of stuff that may be pre-written, and it may help you a little more to build those tools later. Now, what about security? This is another big issue. It's not just an afterthought. When you're doing infrastructure as code, you're kind of pulling all this stuff in, you're building a lot of things, and security traditionally has been an afterthought. It's come through, and a lot of people don't think about security until something's getting pushed out to production for the first time, because dev has their sandboxes, they're doing their own thing. And then when it's turning over to production, that's when you need to file a bunch of port requests and security requests and things like that. Now, if you bring security in and you shift a lot of this stuff left, which if you think about the development and deployment cycle like a timeline from left to right, you've got your build, your design, your build, your test, your deployment, and everything like that. If you take security and you bring it all the way back into like the build and test side, and you shift that over left, then you're able to find and fix security issues faster before you take a lot of steps and you deploy something out and you realize it doesn't work. So the faster you fail and find issues, the faster you can fix that and move on. It's better to take, say, one step back instead of taking 5 steps back. Now, with security, there are a lot of infrastructure as code specific tools out there like Terrascan or Chekhov that can help you make sure that you're finding any security holes or misconfigurations or anything like that before they're actually deployed. For instance, if you're working in AWS and you're deploying an S3 bucket, you don't necessarily want to deploy an S3 bucket that's open to the public if you're going to put sensitive data in there. So this kind of allows you to go through and make sure that everything's good before the deployment goes through. There's also Open Policy Agent that will help you make sure that you're staying within your designated guardrails. Say you're only allowed to deploy to a certain region or a certain size of instance. You can actually write these checks yourself so that you can make sure that you're working with your security team, you're working with your compliance team, and you're following all these rules so that you can speed up the development and iteration process and the deployment process while still staying within the desired, compliance or security guardrails. So what about some code pitfalls here? One of the biggest ones is going to be default values. When you're coding something, or let's take even a step back from that. If you're going and you're deploying stuff out into the cloud, it goes step by step by step, possibly through a wizard, like if you're deploying an EC2 instance in AWS. It's got a bunch of things that you need to fill out, questions you need to answer before it'll deploy it so that it can fill out all of these values and deploy. Now, if you're using infrastructure as code, you may not necessarily write the code that designates a specific value. So what happens with these default values? Maybe there's a default that it deploys to if nothing is specified that you may not want. What happens if you leave it blank? What happens if you use the wrong value? This would have you going through and deploying stuff that you may not want deployed that way. It may have a default IAM policy that is a little more open than you would want on something secure. So how do we mitigate an issue where we're writing code and we don't necessarily inject the right variables or even create the right variable values, and we end up with a default that's incorrect? We talked about open policy agent a second ago, and that's exactly how we can help mitigate some of these issues. We can write policy as code that we can run a check on before deployment so that we can make sure we don't have any incorrect variable values. We're not using a default value that's either insecure or not what we're actually looking for. This is always something that we can go through. These days, we're talking about infrastructure as code. Now we've got policy as code. There's security as code. There's pretty much everything as code. An open policy agent gives you the flexibility to write whatever type of policy that you want so that you can make sure not only are you staying within your security and your compliance standards, but also that you're mitigating any default value issues that you may have so you don't have any deployment problems. There's also the coding methodology of dry, or don't repeat yourself. This is a methodology that kind of helps cut down on code waste and things like that so that you don't have multiple copies of the same code that do basically the same thing with maybe a little bit of change. So how do we work and mitigate dry issues? Now, with infrastructure as code, there's certain frameworks that give you the ability to work and mitigate some of these code duplication issues and write cleaner, less code as well. Terraform modules are one of those things. So if you're going to use basically the same code over and over to, say, create a VPC or a VNet or an instance or a database, you can write one set of that code and then just use it over and over and over like a cookie cutter, and just maybe inject in some specific variable values to customize it, say with a different VPC name or maybe a different IP block or something like that. That allows you to create a lot more dry code that you can reuse so that you don't have 50 different copies of the same code wasting space and then you have to maybe go and update them all. If you need to update that base module, you just update that code once, and then you can go through and redeploy all your modules with the correct variable values. There's also things like TerraGrunt, which allow you to create a little more dry code where you have one copy of your infrastructure as code files, and then you use little configuration files that inject all of those different deployment variables every time, so that you can use the same code for your production, for your staging, for all of the different regions and things like this. So it allows you to, have to create and manage a lot less code, which is going to save you a lot of time going down the road. There's also designing for state size. So when you're using infrastructure as code and you deploy, you end up with what's called a state. Usually this is just a file that tells you, hey, this is what I have deployed. So that when you go and you redeploy something, for instance, your framework is going to check the state that you already have, and then it's going to make the configuration changes. For example, if the first time you deploy, you have 3 instances, you go and you change your infrastructure as code files to deploy to have 4 instances. When that runs, it's going to check the state. It's going to say, oh, I don't need to deploy 4. I've already got 3. So it's going to add 1. Now, this can get hairy if you've got a lot of objects inside of one single configuration file, which that way you're going to end up with one giant state file. This can cause performance issues when it's running because every single time you make a little change or make a deployment, it's going to have to check that entire state file, which if you're designing it big, it would have all of your networking, your instances, your databases, and everything kind of smashed into one. So how do we mitigate state size issues? The good news is we actually just already learned that. It's going to be that dry or don't repeat yourself methodology, but it's going to be a little bit different. Instead of going through and just writing all of these different code and doing it to save yourself time, you're actually doing it not only to save yourself management of the code, but also in deployment times. So if you are using these Terraform modules or these, TerraGrunt modules, all you have to do is update that one little bit of piece of code. And then when you do your deployment, as long as you have either your pipeline or your, deployment technology set up correctly, it's only going to check the state and redeploy that one module. For instance, I've seen customers that have deployments that have upwards of 200 different modules in it. Now, if all of these modules were written into one set of code, it's going to have to go through and check every bit of that huge state size every single time they need to deploy. If they just need to, for instance, change the VPC a little bit or an instance a little bit, it's going to have to go through, upwards of hours of deployment time just to update one little thing. If you have these broken up into modules or you're using, TerraGrunt, for instance, it's only going to check and redeploy that one module. Now, you could have your deployment set up where you have prerequisite triggers so that every time your VPC is updated, it's also going to update, your database or anything else that may need to be rerun at the same time. But it'll save you a lot of that on that deployment because it's not having to go through and check everything. So when you are designing your code, designing it in a modular or dry format will help you keep your state sizes down. Now, of course, you'll have multiple states to deal with, but that's a lot easier on the deployment and management as long as you set up your automation practices and things like that a little better. Hopefully this was helpful for you, whether you've just started out with infrastructure as code or if you're just going through and you've already started a little bit. Hopefully you don't have to go back and start all over again. But if you do have more questions or anything like that, I'm always available on Twitter. That's the best way to get to me, @vtimd. There is also a ton of different resources out there on all of the different infrastructure as code frameworks, how they work, a lot of community support. So definitely be sure to check that out. And I look forward to hopefully meeting up with you in person here at another conference going forward. Have a great day, and thanks for coming.